Hello, I'm Dan Chagru, Product Marketing Lead for the Application Security Products at Digital.ai, here with Mike Woodard, VP of Product Management for Application Security.
Hi, Dan. Happy to do this with you today.
All right. We're pleased to announce the Ascension platform release for Digital.ai's app security product. This release for app security provides additional benefits to the hundreds of customers who already rely on us to protect the applications they create. In this brief broadcast, we'll describe the key capabilities and features of our core product suite, including what's new in the Ascension platform release for AppSec. We'll also take you on a walkthrough of how all these benefits work together to protect the applications that you create and put out into the wild. Finally, I'll show you where you can get some more information and resources on the AppSec Ascension product release. Now, of course, the foundational pillars of what we do for you, our customers, remain the same. First, we protect, by which we mean that we help you build protections into the software that you create at compile. This is what we call putting the sec in DevSecOps, or shifting security left or earlier in the development cycle. You know that you need to build security into your apps because your applications, by definition, contain working examples of how to bypass the security perimeter that you've built. The protections we provide help you make it more difficult for threat actors to tamper with or reverse engineer your apps, which in turn makes it more difficult for them to steal your customers' credentials, bypass authentication, or even breach your firewall to steal IP and/or access your digital crown jewels. Second, we provide a means for our customers to monitor the apps that are running outside their traditional security perimeter for signs of tampering or reverse engineering. And third, we provide a means to react when and if either tampering or reverse engineering is detected. So perhaps first and foremost, or the most important benefit that we provide to protect our customers is that we protect those working examples of how to bypass the perimeter security that your apps contain. We do this by obfuscating the machine code. How do we obfuscate the code? Well, the process is relatively simple for you to implement. We take unprotected binary and feed it, along with the protection blueprint that you create, or we create for you, into an engine that produces the protected binary. The protected app contains obfuscated machine code that runs as originally designed, but is virtually unreadable by threat actors, even after it has been fed into a disassembler. So if you look at the example, on the left, you see unobfuscated and disassembled code. Threat actors would recognize something like the for loop and the if clause in the machine code, and the clever ones will zero in on patterns such as those in order to change the code to do their bidding. For example, they might alter the for loop to automatically return a yes when your end customer attempts to authenticate using a username and password. Now, how did attackers disassemble the code? Once they have an app, and of course, anyone can get just about any app at any time through Apple's App Store or the Play Store, or simply by accessing a web client or buying or downloading a desktop app. Once they have it, they simply run it in a disassembler. Disassemblers are easily available on the dark and gray web for download. The one we use to create the example you see here is called Ghidra, a tool that was originally made by the NSA and open sourced in 2019 to help white hat hackers analyze malware. But like any tool, Ghidra can be used as a weapon, and when it is used as a weapon, Digital AI helps protect yourself from it. Now, obfuscating code is not as difficult as designing and writing code, secure code to begin with. And of course, we advocate that over time, our customers help their designers, architects, and coders design and write secure code. But the sad truth is that not a single university CS program in the US or worldwide requires completion of a course in cybersecurity. So while the industry catches up, we're offering a way to build secure software at compile without requiring your developers to code securely. Again, we do this by writing a protection blueprint customized to the app we want to secure. And now with the release of Ascension, we're able to build secure software without custom building a protection blueprint. We have an auto configuration option that can be added to any compiled binary at build to obfuscate software without requiring any customization or configuration. The next most important way we protect your apps is through the addition of anti-tampering techniques. By anti-tamper, we're primarily referring to the ability to detect two conditions. First, we detect when your apps are run in an unsafe environment that might allow it to be tampered with. Classic examples of these types of environments are debuggers, emulators, and rooted or jailbroken devices. Second, we detect when the code in your app has been modified. In the graphic on the left, we show two columns of code. The left side of the graphic shows a simplified representation of your original code. We check that code line by line against the code we find running in any of the mobile, web, or desktop clients that you have out in the wild. If we see even one line of code that's different from your original code, we send you an alert that your code has been modified. With the Ascension platform release, you have the option to have these anti-tamper techniques applied to your apps for you by Digital.ai in the cloud. So what else is new? Well, the Ascension platform provides the ability to add the fundamental obfuscation and anti-tampering techniques described earlier in this presentation through an easy-to-implement auto-configured protection blueprint. Auto-configuration takes some of the manual customization work out of the protection blueprint design and thus allows you to protect more applications faster. Protecting more apps means freeing up security engineers to work even earlier in the DevSecOps lifecycle, for instance, on secure design or secure coding. It also allows those of you who are just beginning to implement DevSecOps to protect apps while or even before your developers are learning how to code securely. The auto-config option in the Ascension platform provides the ability to obfuscate application code, including string renaming, and the ability to provide both basic and advanced anti-tampering measures, such as identity verification or identifying if code has been modified, virtual control detection, or the ability to operate an app without user input, and virtualization detection, which basically detects when an app is run in an environment other than the device it was meant to be run on. Now, as with any security product, designers, architects, engineers, and InfoSec teams have to make trade-offs between ease of use, performance, and strength of protection. Some consider running in the cloud versus on-premises to be one of those trade-offs. With the addition of our Ascension platform release, you now have maximum flexibility to apply the level of protections that you want and need using the deployment option that you're most comfortable with. You can implement all of these protections, including customized protections, on premises. You can choose to auto-configure your protections on premises, as I mentioned earlier in the previous slide, or you can choose to have some protections added for you through deployment in the cloud. Now, the final improvement that I wanted to announce with our Ascension product release is better visibility into 1, attacks on your apps, and 2, attempts to run your apps in unsafe environments. What you're looking at here is a report of a threat actor's attempt to do the former. More specifically, an attempt to modify JavaScript. JavaScript would, of course, typically be part of a web app or a mobile app. The monitoring happens after the protection blueprint has been built for inclusion at the build stage. The app can be protected in dozens or even hundreds of ways. What we're looking at here is a report of an attempt to modify a script. So starting at the top left of the screen, you see that we're looking at script modification alert. The protection mechanism is called, not surprisingly, the script verification protection, and the type of event is script verification. In short, you're seeing that a threat actor has attempted to modify your script. You're also seeing a wealth of detail about where and on what device, OS, and browser the modification took place. You have at your disposal the IP address of the device, the geographic location of the threat actor, or at least the IP address of the threat actor service provider. You can also see the OS on which the modification occurred. In the middle of the screen, you see the time that the modification occurred and the time it was detected. These two times are typically the same unless the threat actor managed to take the script offline, make the modification, and then add it back into the app at a different time. On the bottom right, you see the unique app instance. This shows you the unique installation of a protected app on a specific device. And finally, you can see the browser, the user agent within that browser, the URL where the mod occurred, and the specific script that was modified. Other improvements in the Ascension platform release are listed here. The important point I'd like to make for you to take away is that Digital.ai offers security for apps created across the widest range of platforms. That's desktop, web, and mobile, the widest range of OSs, including iOS, Android, watchOS, tvOS, Mac, Windows, and Linux desktop, and languages such as C, C++, C#, JavaScript, HTML5, and more, and attack tools. And we release product updates to ensure compatibility with each successive release of those updates. In fact, since October of 21 alone, we've released over 18 patches, point releases, and updates. Okay, so at this point, I'd like to welcome Mike back to the broadcast to walk you through some of the protections I've just described and explain what makes those protections unique.
Thanks, Dan. So, as noted, digital AI application security provides a means to build secure software. Our customers find value in building protections into their software because the investments they make in perimeter security are necessary, but not useful against the types of application attacks that we help them protect against. I like to use word pictures to help explain ideas that can be hard to understand. Let me try that now. Have you ever wondered why in the original Star Wars, the Empire would ever allow plans for the Death Star to be leaked when those plans provided information needed to destroy it? Who would ever do that? Unfortunately, the answer is that every company that distributes an application that talks to corporate back-end systems has done just that. Those applications are working examples of how to bypass firewalls and every other perimeter protection mechanism. It's like posting plans for your Death Star in the App Store. Now, given that those apps need to work with back-end systems, it is incumbent that app publishers make it as hard as possible to extract secrets from their apps and make it as hard as possible to modify those apps for nefarious ends. So you see on the screen here, the app on the left leaves all the secrets exposed, the plans of the Death Star out in the open. Using our protection products on the right can protect your data, code, and resources, can detect several kinds of unsafe environments and modified code. Each of those detections can report to our monitoring system and/or put other obstacles in the way of attackers. And what you see here is one of the unique differentiators for Digital.ai application security, the guard network. The guard network greatly increases the protections you enjoy by providing defense in depth through what we call intersecting fields of fire, which can be thought of as a kind of buddy system. By buddy system, we mean that individual protections detect when another protection is being manipulated. Because the guard network protects your apps through this buddy system, an attacker must simultaneously disable all guards at once to effectively crack an app. This is different from how a lot of our competitors' products work, where each of the protections is standing on its own and can be removed one by one. The guard network is specified as protection techniques that we can help your build engineer or security architect write, and are what we refer to as protection blueprints that make up the individual protections we offer. The blueprints ensures that protections spread throughout the code, and each one looks after and checks on the others for signs of tampering. That means that any attacker would have to neutralize each protection separately and simultaneously in order to successfully crack or hack an application. So protections are specified by build engineers or security architects. Protections are injected at build time and are merged into the final binary to keep from introducing edges between original code and protection mechanisms. The protection blueprints allow customers to create custom protections that are easily varied build by build, and each build can have a completely different appearance to the attacker. Back to you, Dan.
So thank you, Mike, and thank all of you out there for taking the time to learn more about the app security improvements in the Ascension platform release. If you'd like to find out more, you can find information on the revamped app security section of the digital.ai website. If you're an existing customer or have a login to the App Security Dev portal, you can also browse our updated technical documentation there. Okay, that just about wraps things up. If you have questions, contact either me, daniel.chagru@digital.ai, or Mike Woodard at mike.woodard@digital.ai. Thank you very much for attending the Ascension platform release for application security.